We're now going to look at how you can use L'Hopital's rule to find limits of indeterminate differences, meaning we have an infinity minus infinity. So we're going to look at the example where we're trying to take the limit as x goes to 1 from the right of 1 over x minus 1 minus 1 over the natural log of x. So if we look at these limits individually, the limit as x goes to 1 from the right of 1 over x minus 1, that's going to infinity. You could look at the graph. And if you looked at the graph of 1 over natural log of x, as we go to 1 from the right, that's also going to infinity, because if you remember, the natural log of 1 is equal to 0. So in both these cases, we have things that would look like 1 over 0, and in both cases, they're going to positive infinity. So what we're going to do is we're going to get a common denominator to combine these functions to write it as one fraction. So here we're just doing a little bit of algebra. Our common denominator will be x minus 1 times natural log of x. Sorry, that should just be a 1. Natural log of x. Now up top, the first fraction we're going to have to multiply by natural log of x over natural log of x. So we'd have natural log of x minus, and then the second fraction we're going to have to multiply by x minus 1. And we want to be careful about the parentheses so that we remember to distribute the negative. So here we'll have the limit as x goes to 1 from the right. Just going to clean this up a little bit. Natural log of x minus x plus 1 over x minus 1 natural log of x. So now, if we think of plugging 1 in, we would have natural log of 1, which is 0, minus 1 plus 1. So we would get 0 in the numerator, and we would get, if we plug 1 in here, we would have 0 times 0. So we get 0 in the denominator. So now that this is the 0 over 0 case, we can apply L'Hopital's rule. So when we apply L'Hopital's rule, we're going to have the limit as x goes to 1 from the right. We're going to take the derivative of the top, so the derivative of natural log of x will give us 1 over x. And then we'll have minus 1 over, and in the denominator here where we have x minus 1 natural log of x, we're going to have to use the product rule. So I'm going to leave the x minus 1 alone, take the derivative of natural log of x, so times 1 over x, plus, now we take the derivative of x minus 1, which is just 1, times natural log of x. Okay. Now, before we go any further, we're going to clean this up a little bit. So I'm just going to go to a new slide and rewrite what we had. So we had the limit as x goes to 1 from the right of 1 over x minus 1 over x minus 1 times 1 over x plus natural log of x. So if we think of combining our fractions in our numerator, getting a common denominator, which would be x, we would have the limit as x goes to 1 from the right of 1 minus x over x, if we just write 1 as x over x. And then in the denominator, again, the denominator of the fraction we'll have will be x. So up top we'll have x minus 1 plus x natural log of x, because we have to multiply the natural log of x by x over x. Okay, now that we can do that, we can see that when we multiply by the reciprocal of our denominator, these x's are going to cancel out. And we're left with the limit as x goes to 1 from the right of 1 minus x over x minus 1 plus x natural log of x. Okay, now, again, we want to try direct substitution. And when we plug in 1, we would get 0 in the numerator. And if we plug in 1 to the denominator, we're going to have 1 minus 1, which would be 0, plus 1 natural log of 1. And since natural log of 1 is 0, again, we get 0 over 0. So we can apply L'Hopital's rule again. And we would have the limit as x goes to 1 from the right of -1 over 1, the derivative of x, the derivative of -1 is 0, so plus, then for x natural log of x, we need to do the product rule. So we'll leave x alone, multiplied by the derivative of natural log of x, which is 1 over x, plus, now we will take the derivative of x, which is 1, times natural log of x. Okay, and we see here we would get, if we now use direct substitution, we're going to have -1 over 1 plus 1 times 1 over 1, so 1, plus the natural log of 1 is 0. So here our final answer is -1/2. So we've shown that our limit from the beginning, the limit of, as x goes to 1 from the right, of 1 over x minus 1 minus 1 over natural log of x is equal to -1/2.